In a 2004 study at the University of Missouri, psychologist Moshe Naveh-Benjamin showed older adults 20 photographs of unfamiliar faces paired with names. They remembered the faces, they remembered the names, but when asked to match the correct name to the correct face, their accuracy collapsed, dropping 30 to 40% below younger adults. Your brain after 50 is not losing names. It is losing the connection between the name and the face. That is a completely different problem, and it has a specific, fixable cause. Most people over 50 assume they are forgetting names because their memory is failing. That assumption is wrong, and believing it makes the problem worse. Here is what is actually happening. Your brain processes a face and a name through two entirely separate neural pathways. The face goes through the fusiform face area in your temporal lobe, a region specialized for recognizing visual identity. The name goes through the left anterior temporal lobe and connects to phonological nodes, the sound patterns that form spoken words. In young brains, these two pathways converge effortlessly in the hippocampus, which binds them into a single memory unit. You see a face, you hear a name. The hippocampus ties them together like a knot. After 50, that knot starts slipping. Not because your hippocampus is dead, but because the signal strength between these two pathways weakens. Neuroscientists call this an associative binding deficit. Your brain can still process the face. It can still store the name, but the thread connecting one to the other thins with each passing year. This is why you will see someone at the grocery store, recognize them instantly, know where you met them, know what they do for a living, and still stand there unable to produce their name. The information exists in your brain. The bridge to it has eroded. But the question that changes everything is, why does this specific bridge erode faster than almost any other memory function? And what triggers the erosion to accelerate after 50? The answer starts with a molecule you have been losing since your early 20s: dopamine. Research published in the journal Synapse and reviewed extensively by Lars Bäckman at the Karolinska Institute in Stockholm estimates that the dopamine system declines at a rate of 5 to 10% per decade from early adulthood. In the prefrontal cortex, the region responsible for effortful retrieval of stored information, that decline hits particularly hard. By 60, you may have 30 to 50% less dopamine receptor availability in your frontal lobes than you had at 30. Why does this matter for names? Because retrieving a proper name from memory is one of the most dopamine-dependent cognitive tasks your brain performs. Think of it like this. Every word you know sits in a mental dictionary. Common nouns, chair, dog, hospital, have dozens of connections pointing to them. You can reach chair from its shape, its function, its location, its material. There are many roads leading to that word. But a proper name, Margaret, Robert, Suzanne, has almost no semantic connections. It is an arbitrary label attached to one specific person. There is essentially one road leading to it, and that single road is paved with dopamine-dependent neural transmission. Dr. Deborah Burke at Pomona College in California developed what is now called the transmission deficit hypothesis in 1991. She proposed, and decades of research have since confirmed, that tip-of-the-tongue experiences are not caused by competing words blocking your access to the target name. They are caused by weakened signal transmission along the single connection between a name's meaning node and its sound node. Your brain knows exactly who you are looking at. It has activated the correct semantic representation. But the signal traveling from that representation to the actual phonological structure of the name, the sounds that form Margaret, is too weak to complete the trip. This is why the tip-of-the-tongue state feels so maddening. You are not confused. You are not lost. You can feel the word there. You know the first letter. You know how many syllables it has. Sometimes you can even hear a similar-sounding word. But the full phonological form will not fire. The transmission fails at the last link in the chain. A 2020 longitudinal study published in Frontiers in Psychology tracked tip-of-the-tongue frequency across aging and found that proper names account for the overwhelming majority of these failures, far more than common nouns, verbs, or adjectives. And the rate increases measurably decade by decade after age 50. Some researchers estimate that adults over 65 experience name retrieval failures at roughly double the rate of adults under 35. But here is the part nobody mentions. This transmission weakness is not permanent. It is not structural damage. It is a signal strength problem, and signal strength can be rebuilt. What comes next is the mechanism that rebuilds it. The hippocampus sits deep in your temporal lobe, one on each side of your brain. It is roughly the size and shape of a seahorse, and its primary job, when it comes to names and faces, is binding. Binding means taking two unrelated pieces of information, a visual pattern and an auditory label, and welding them together into one retrieval retrievable memory. In 2017, researchers at the University of California, Davis published a study in the Proceedings of the National Academy of Sciences examining individual differences in associative memory among older adults using high-resolution fMRI scans. They found that older adults who maintained strong face name memory had measurably thicker hippocampal subfields, specifically a region called CA3/dentate gyrus, compared to those whose associative memory had declined. The physical integrity of this region predicted performance better than overall brain size, education level, or even total hippocampal volume. Here is what that means for you. The hippocampal cells responsible for binding names to faces are still alive in most healthy adults over 50, but they have become underactive. Like a muscle that has not been loaded in months, they are capable of function, but are not being asked to function. If you have ever woken up at 2 a.m. and suddenly remembered the name you could not recall at dinner, that is proof. Your hippocampus eventually completed the binding. The connection was there. It simply needed more time and less interference to fire. The issue was not storage. It was retrieval under pressure. Now here is where the two problems compound each other. Dopamine decline weakens the transmission signal. Hippocampal underuse weakens the binding infrastructure. And there is a third factor amplifying both. Your anterior temporal lobes are physically thinning. A 2017 study from the University of the Basque Country, published in Brain and Cognition, measured cortical thickness in middle-aged adults and compared it to their ability to retrieve proper names. Thinner left anterior temporal cortex predicted significantly worse name retrieval and significantly more tip-of-the-tongue failures. This was not measured in Alzheimer's patients. These were cognitively healthy individuals aged 50 to 70. Normal aging was sufficient to thin the exact brain region that retrieves names. If this is making sense and you want the protocol, the specific daily practices that rebuild transmission strength and retrain your hippocampal binding, subscribe now. That section is coming in 4 minutes. It is the part that turns this knowledge into something you can actually use tomorrow morning. But none of this explains why names are uniquely vulnerable, why your brain loses access to Margaret decades before it loses access to teacher or friendly or lives next door. The answer to that is the hidden architectural flaw in how your brain stores proper names, and understanding it changes how you should learn names from this day forward. What almost nobody talks about is this. Proper names are stored differently from every other word in your vocabulary, and this storage architecture creates a built-in weakness that aging exploits ruthlessly. When you learn a common noun, say piano, your brain creates a web of connections. The word links to sound, to shape, to function, to emotional memories of hearing one played, to the physical sensation of pressing keys, to categories like instrument and furniture. If one connection weakens, you still reach the word through another route. It is a redundant system. Multiple paths lead to the same destination. But a proper name has almost zero semantic redundancy. Robert does not mean anything. It does not connect to any category. It does not link to a shape or function or sensation. It is an arbitrary sound pattern attached by a single thread to one specific face. In node structure theory, developed by Burke and Mackay, this architecture is represented as a single connection between the person's semantic node and their name's phonological node. One connection, no backup routes, no redundancy. This means that when aging weakens connection strength, even slightly, common nouns survive because they have backup routes. But proper names fail because their single connection drops below the activation threshold. It is the difference between a bridge with one cable and a bridge with 50 cables. Cut one cable on the 50-cable bridge and it still holds. Cut the one cable on a single cable bridge and the entire structure collapses. This is why a 72-year-old professor who can deliver a flawless 2-hour lecture on quantum mechanics cannot remember the name of the student sitting in the front row. The knowledge is not gone. The single cable to the name has gone slack. A 2011 study by Dr. Leah Ross at the University of Pennsylvania demonstrated this architecturally. She applied mild electrical stimulation to the left anterior temporal lobes of older adults during a face naming task. Stimulation of this specific region, the endpoint of the name retrieval cable, improved proper name recall compared to sham stimulation. The hardware still works. The The signal just needs amplification. The implications are direct and practical. You cannot change the architecture of how proper names are stored. That single cable design is permanent. But you can do two things: strengthen the cable through repeated activation and build artificial backup connections through encoding strategies that give the name additional semantic and visual links. In other words, you can retrofit a single cable bridge into a multi-cable bridge manually every time you learn a name. The question is how. Here is the protocol. 4 steps to rebuild your face name binding system. Each targets a specific mechanism. Step 1. Elaborative encoding at the moment of introduction. When you hear a new name, you have approximately 5 seconds before your brain begins discarding the acoustic trace. In those 5 seconds, do 3 things. First, repeat the name aloud. Nice to meet you, Margaret. Second, visually link the name to one distinctive facial feature. Margaret has a mole above her lip, and you picture a tiny M branded there. Third, create one absurd semantic association. Margaret sounds like march. You imagine her marching in a parade. This process takes under 10 seconds and converts a single cable connection into a 3-cable connection. You now have a phonological root, a visual root, and a semantic root to the same name. Step 2. Spaced retrieval practice within the first 24 hours. Research on spaced retrieval, refined by Dr. Cameron Camp at the Myers Research Institute, shows that actively attempting to recall a name at expanding intervals dramatically strengthens the hippocampal binding. After meeting Margaret, try to recall her name at 1 minute, 5 minutes, 30 minutes, and the following morning. Each successful retrieval strengthens the connection exponentially. Each failure, followed by relearning, is nearly as beneficial. The timing matters. 4 retrieval attempts in 24 hours produce retention rates above 80% at 1 week, compared to below 30% with no retrieval practice. Step 3. Aerobic exercise 3 to 5 days per week for a minimum of 25 minutes at moderate intensity. This targets dopamine. A meta-analysis published in Neuroscience and Biobehavioral Reviews in 2020 reviewed 22 studies and confirmed that regular aerobic exercise increases dopamine receptor availability in the prefrontal cortex of older adults. More dopamine means stronger transmission along the name retrieval pathway. The same exercise simultaneously increases BDNF, brain-derived neurotrophic factor, which supports hippocampal neurogenesis. You are fueling both the cable and the junction box simultaneously. Step 4. Daily active name retrieval practice. Spend 5 minutes each evening looking at photographs of people you know, family, friends, colleagues, public figures, and deliberately produce their names aloud. Do not just recognize them. Force retrieval. This is resistance training for the transmission pathway. Dr. Burke's research consistently shows that recent and frequent use of a name strengthens the phonological connections. Every name you actively retrieve today is easier to retrieve tomorrow. If even one of these steps was new to you, hit like. It signals the algorithm to show this to more people dealing with the same frustration. Dr. Bherer at the University of Montreal has been researching combined physical and cognitive training in adults over 60 since 2010. Her lab consistently finds that combining aerobic exercise with structured cognitive practice produces larger improvements in memory than either intervention alone. The synergy is not accidental. Exercise amplifies the brain's capacity to benefit from cognitive training by raising BDNF and dopamine simultaneously. Here is what most people get wrong about name memory after 50. They treat every failure as evidence of decline, every blank moment as proof that their brain is deteriorating. And that belief, that passive acceptance, becomes a self-fulfilling prediction. Because the less you try, the weaker the connections become. The weaker the connections become, the more you fail. And the more you fail, the less you try. The truth is simpler and more demanding. Your brain did not forget how to bind names to faces. It forgot that you were going to ask it to. It downregulated a system you stopped exercising, and it will rebuild that system the moment you resume asking. Not overnight, not perfectly, but measurably, within weeks of consistent practice. I want to hear from you. Drop a comment. What is the most embarrassing name forgetting moment you have experienced? And did you use any strategy afterward, or did you just accept it? The neuroscience is clear on this. Tip of the tongue failures for names are signal strength problems, not storage problems. The name is still in your brain. The road to it has grown over with disuse, and roads can be cleared. You do not forget names. You stop retrieving them. Share this with someone who complains about their memory. And if you have not subscribed yet, do it now. Next week, I am covering a single 10-minute evening practice that researchers at Stanford are using to reverse measured age-related memory decline. The data behind it is remarkable. Your brain is waiting to be asked harder questions. Give it a reason to answer.